A very good morning, friends. Today we'll continue lecture number 6 on differentiation. In this lecture, we'll be doing derivative of inverse function. So we'll start derivative of inverse function. The first theorem is if y is equal to fx be a differential function of x such that x is equal to f inverse y is defined, then prove that dy by dx dx by dy. See, y depends upon x. So if there is increment delta x in x, there will be increment delta y in y. Let delta x be a small increment let corresponding increment in y be delta y. As delta x tends to 0, delta y also tends to 0. In usual notation, delta y by delta x into delta x by delta y is 1. Here delta x, delta y are increments. So they are different numbers, delta y divided by delta x. So it is ratio. So delta y cancel, delta x cancel. We'll get 1. Therefore, delta x by delta y is what? 1 upon delta y by delta x. Taking limit as delta x tends to 0, we get limit delta x tends to 0, delta x by delta y is equal to therefore limit delta y tends to 0, because in denominator we have a delta y, so we want delta y tends to 0. 1 upon write this as equation number 1. reason as delta x tends to 0, comma delta y also tends to, since y is given to be differential function of x, differentiable function of x, therefore limit delta x tends to 0, delta y by delta x will exist and finite, therefore limit delta x tends to 0, delta y by delta x is equal to dy by dx. Since limit on right hand side of equation 1 exist, therefore limit on left hand side of equation 1 will also exist and limit delta y tends to 0, therefore equation 1 becomes dx by dy is equal to 1 upon dy by dx, provided dy by dx is not equal to 0. Now we'll be doing all derivations, sine inverse, cos inverse, tan inverse, everything. In that, first one is what? Derivative of sine inverse. Y is equal to sine inverse x, where modulus x less than or equal to 1 and minus pi by 2 less than or equal to y less than or equal to plus pi by 2. So x will be what? Sine y. Now x is differentiable function of y. So differentiating with respect to y, we get derivative of x with respect to y is equal to cos y. So dx by dy is what? Plus minus root 1 minus sine square plus minus root 1 minus reason from 1. Now we have to decide whether it is positive or negative sign. Since minus pi by 2 less than or equal to y less than or equal to pi by 2, that is y lies in first or fourth quadrant. In both the quadrants, cos y is positive. Why cos y? This is the value of cos y. In place of cos y, we have written this. And cos y is what? Positive in both the quadrants. Therefore, dx by dy is positive root 1 minus x square by derivative of inverse function dy by dx is what? 1 upon dx by dy, provided one upon root provided here modulus x is what? Less than or equal to 1 in the definition, but this time in derivative it will be what? Less than 1. So d by dx of y is what? Sine inverse x is what? 1 upon root 1 minus x square. Next is y is equal to cos inverse x. Then prove that dy by dx is equal to minus 1 upon root 1 minus x square provided mod x is less than 1. Y is equal to cos inverse x, where modulus x less than or equal to 1 and 0 less than or equal to y less than or equal to pi. So y will be what? Cos inverse x means x is cos inverse y. X is cos inverse, sorry, cos y. Now x is differentiable function of y. So differentiating with respect to y, we get derivative of x with respect to y is what? Minus sine y. Minus sine y is written as root 1 minus cos square. When you are writing root, it will be plus minus. this minus is there, plus minus root and cos y is what? X. From 1. By derivative of inverse function dy by dx is what? 1 upon dx by dy provided dx by dy not equal to 0. Sorry, we have to decide whether. 1 minute, 1 minute, 1 minute. Since 0 less than or equal to y less than or equal to pi, that is y lies in first or second quadrants. In both the quadrants, sin y is positive. This is the value of sin y. This minus is there. This is the value of sin y. And sin y is positive. So, dx by dy will become, outside is minus sign, inside will be positive root, will give minus root by derivative of inverse function dy by dx is equal to 1 upon provided dx by dy not equal to 0. So dy by dx is what? 1 upon minus root provided modulus x less than 1. Therefore, dy by dx of cos inverse x this is derivative of cos inverse x. Next is y is equal to tan inverse x. Where x belongs to R, entire real line, and minus pi by 2 less than y less than plus pi by 2. Therefore, x will be what? Tan y. Differentiating with respect to y, we get dx by dy sec square y, and sec square can be written as 1 plus tan square, 1 plus from 1. Now there is no plus minus, so we don't have to decide. By derivative of inverse function dy by dx is what? Provided dx by dy not equal to 0. Therefore, dy by dx is equal to 1 upon d by dx of tan inverse x is what? One upon 1 plus x square. Next is y is equal to cot inverse x, where x belongs to real number and 0 less than y less than pi. So x is what? Cot y. Differentiating with respect to y, we get derivative of x with respect to y is what? Minus cosec square y. Cosec square y is what? 1 plus cot square y. One plus x square region from 1. By derivative of inverse function dy by dx is equal to provided therefore dy by dx is what? So d by dx of cot inverse x is equal to minus If y is what? Sec inverse x, then prove that dy by dx is what? 1 upon x root x square minus 1 for x greater than 1, or dy by dx is what? Minus 1 upon x root x square minus 1 for x less than minus 1. See the proof. Since y is equal to where modulus x is what? Greater than or equal to 1, and 0 less than or equal to y less than or equal to pi, and y should not be pi by 2. So x is what? Sec y. Differentiating with respect to y, we get derivative of x with respect to y is what? Sec y into tan y. Dx by dy is what? Now tan y is replaced by a root of the moment we write root, it will have two signs, either positive or negative. We have written plus minus. So dx by dy is what? Plus minus. Sec y is what? X root x square minus 1 from 1. Since 0 less than or equal to y less than or equal to pi, and y is not equal to pi by 2, that is y belongs to 0 to pi by 2, where pi by 2 is not included, union pi by 2 to pi, that is y lies in first or second quadrant. In first quadrant, both sec y and tan y are positive, so their product will also be positive. Therefore sec y into tan y will be positive. In second quadrant, both sec y and tan y are negative. Therefore sec y into tan y will be positive. Hence, dx by dy is what? Positive x root x square minus 1. Here x is what? Modulus x is greater than 1. Therefore, by derivative of inverse function, dy by dx is what? 1 upon dx by dy, provided dx by dy not equal to 0. So dy by dx is what? It will be 1 upon x root modulus x is what? Greater than or equal to, and it is positive, so modulus x is what? Greater than 1. That is d by dx of sec inverse x will be what? 1 upon x root if x is greater than 1 is equal to minus 1 upon x root because modulus x greater than 1 means either x is what? Greater than 1 or x is less than minus 1. So whenever x is less than minus 1, its value is what? Positive. So x must be negative. If x is negative, then negative of negative will make positive. So we have to take care of this. Last derivation is what? Cosec inverse x. Since y is equal to cosec inverse x, where modulus x is greater than or equal to 1 and minus pi by 2 less than or equal to y less than or equal to pi by 2 and y should not be 0. Therefore, x is what? Cosec y. Now x is a function of y, so differentiating with respect to y. So dx by dy is what? Minus cosec y cot y. This minus is there. Cosec y, cot y can be written as root cosec square y minus 1. This minus is there. Cosec y is what? X root. The moment we write root, we had to write plus minus. Now we have to decide whether it is positive or negative. Since minus pi by 2 less than or equal to y and y is not equal to 0, that is y belongs to minus pi by 2 to 0 union 0 to pi by 2. That is, y lies in first or fourth quadrants. In first quadrant, both cosec y and are positive. Therefore, cosec y into cot y will be positive. In fourth quadrant, both cosec y and cot y are negative. Therefore, cosec y and cot y will be positive. Therefore, dx by dy is what? Outside is negative. This will be positive. Minus x root by derivative of inverse function dy by dx is what? 1 upon dx by dy, provided dx by dy so dy by dx 1 upon x root with negative sign, provided instead of equal it is just greater than 1. If it is equal, the inter will become 0. That is d by dx of cosec inverse x is equal to minus 1 upon x root x square minus 1 if x is greater than 1. It is equal to 1 upon x root less than 1. Now problem based on derivative of inverse function. First, we need to find out x in terms of y, and then we have to differentiate. Since y is what? So x will be y squared. Differentiating with respect to y, dx by dy is what? 2y, and y is root x. By derivative of inverse function, we want dy by dx. Which is 1 upon 2 root x. See second. Y is root of so y square will be what? So root x is what? X is 2 minus y square raised to 2. Now x is a function of y. Differentiating with respect to y. First we take derivative of power. 2 times into derivative of inside function. Minus 4 into y into 2 minus y is root of and 2 minus y square is what? Root x. From 1 and 2. Since or by derivative of inverse function, dy by dx is what? One upon dx by dy minus 1 upon 4 root x 2 minus root x. Y cube is what? X minus 2. y is cube root of x minus 2. So y cube is what? X will be what? Y cube minus 2. Differentiating with respect to x, with respect to y. We get dx by dy is what? 3y square. Y square means cube root of x minus 2 which is same as 3 times x minus 2 raised to 2 by 3 by derivative of inverse function 1 upon dx by dy. 1 upon 3 into x minus 2 raised to 2 by 3. The next is y is equal to e raised to y is what? So 2x is what? So x is 1 plus e raised to y upon 2. Differentiating with respect to y. Derivative of x with respect to y is what? 1 by 2 is constant, take outside 0 plus e raised to y. By derivative of e raised to y is nothing but 2x minus 1. We are interested in dy by dx. Two upon 2x minus 1. Repeat. Y is 2x plus 3, therefore 2x is y minus 3, x is y minus 3 upon 2. Differentiating with respect to y. So dx by dy is what? By derivative of inverse function dy by dx is what? x by 2 to the base 2. So 2 raised to y is what? X is what? 2 into 2 raised to y. Differentiating with respect to y, we get dx by dy is what? 2 into 2 raised to y log 2. And 2 raised to y is what? X by 2. To cancel x log 2. From 1. By derivative of inverse function dy by dx is what? 1 upon dx by dy. 1 upon x log 2. Next is y is equal to e raised to log y is what? X is 3 plus log y. Differentiating with respect to y, so derivative of x with respect to y is what? By derivative of inverse function dy by dx is what? And 1 upon e raised to e raised to x minus 3. Thank you very much. Some people dream of success while others wake up and work hard at it. कुछ लोग सिर्फ सोते सोते सपने देखते हैं, अच्छे सपने देखते हैं, लेकिन कुछ लोग जाग कर उठकर उस सपने पे कार्य करते हैं, हार्ड वर्क करते हैं, मेहनत करते हैं, एंड दे अचीव इट. थैंक यू.